Welcome. In this video I'm going to show you how you can determine Johnston-Berry-Mielke E, which is an effect size measure that you could be using if you have a goodness of fit test using Microsoft Excel. It is actually described in their article, which is shown here at the bottom under references. Now, to show you how to actually calculate it, I'm going to use some example data, which is over here, which I've also been using to perform a goodness of fit test in an earlier video. For this, we will need the expected values again and the chi-square value. So we're going to calculate that one again. I'm going to do this quickly because I've done it before in my video on performing a chi-square test. So very briefly, this can simply be I need to observed count, so how many times each option was chosen. So I can use a count if, then a semicolon, my range is A, then a semicolon, and then my married. I'm using semicolon for separators between parameters. This could be different on your Excel version. I can then simply copy paste this down, or use the autofill handle, or Ctrl+C, Ctrl+V. And then add the total. Alt equals is a shortcut for sum. So there were 1,941 people who responded their marital status. For this example, I'm going to be using as an expected count the same for each category. So I'm going to use the total. Press F4 to put dollar signs around it so that when I copy paste it down, it won't change. And since I have 5 categories, I divide this simply by 5. Now I can simply copy paste this down and it should be the same for each of them. The chi-square value is now calculated by calculating for each of them the observed value minus the expected value, then close the parentheses, square the result, and then divide by the expected. I can then copy paste this down and then sum them all up to get my chi-square value. Now I also need the lowest expected count, which in my case will be of course any of these because they're all the same, but just to make it nice as a function or as a formula, I can just use the min function. Now I can calculate the JBME, as I simply abbreviated to, by using this formula. It looks scarier than it might actually be. We just follow the numerator, which has multiplications only, so I can just don't need parentheses for that. It's the chi-square value, which we have over here, and multiplied with that E min, which is over here. And then divided by, and then I do need a set of parentheses, the total sample size, which I still have over here, multiplied by another set of parentheses, again that sample size, minus the E min, which was this one, and then close the 2 sets of parentheses. In this case it's 0.16. Now I couldn't really find any rules of thumb for this interpretation. It should always be between 0 and 1. That's the whole point for them to have made this one. And I think we could interpret it as a correlation coefficient. So, but I'm not sure. So if you have any source with rules of thumb for this, let me know and then I can add it in. The original equation, by the way, is slightly different. It's using actually the expected and the observed proportions. If you're really interested, I do have here a separate tab where I follow that calculation, and I even put a proof in here on why those two are actually eventually the same. So if we go all the way down, then I do end up with that exact same one. There is a warning though. For a likelihood ratio goodness of fit test, the formula is slightly different. So this one is slightly different. It does uses those proportions. So I need the observed proportion, which is simply, I have to scroll all the way back up, my frequency divided by the total sample size. I can use F4 again so that the total sample size will not change when I copy paste it down. I then also need the expected proportion, which they call QI. So similar, go all the way back up. I take my expected value and divide it by the total and press F4 again so that there are dollar signs around it. Then copy paste this down or double click. Oh, that's one too many. I then need a logarithm, so as you can see there's the ln, this part in the equation over here. So we can do that simply by using the natural logarithm function from Excel, and it's going to be this one divided by that q. Alright, then I can copy paste this one down, and then all of this needs to be multiplied with the observed proportion. So I'm simply going to say, well, it's this one times and then the observed proportion. Copy all of this down, and then we need the sum of all of this, because that's what this big looking E here stands for, simply to sum all of them up. The Q that you see here is simply the minimum of all the Q's, so min and then all my Q values, and similar as before with the expected counts. Of course the expected proportion, because they're all the same, is just also that one. I can then simply use the formula, which stands to do minus 1 divided by the natural logarithm of that minimum, and multiply the whole thing with the sum of all of these, which is over here, and we get 0.18. Alright, and that's how you can calculate this JBME using Microsoft Excel. I'll leave a link to this worksheet on my website, for which you can find a link in the description below. Thank you for watching, and hope this was helpful.